We're going to evaluate the integral of x times inverse sine of x. First, we'll apply integration by parts. We let u be inverse sine of x, so that du is equal to 1 divided by the square root of 1 minus x squared. And that means that dv is equal to x dx. To go from dv to v, we take any antiderivative. Normally 1/2 x squared is sufficient, but in this case it's better to make v 1/2 x squared minus 1/2. We can certainly do that because the derivative of v is x, and this will help us in evaluating the integral in integration by parts. So factoring 1/2 out, this is 1/2 times x squared minus 1, and we can also write it in the form minus 1/2 times 1 minus x squared, which will again help us in evaluating the integral in integration by parts. So let's go back to the original integral. Integral of x times inverse sine of x dx. This is our u dv integral. It is equal to u times v 1/2 times x squared minus 1 times inverse sine of x minus the integral of v du. I'm going to take this form of v. It has a minus in front, so that means we have a plus 1/2 times the integral. We have 1 minus x squared in the numerator. That's from v, and we have the square root of 1 minus x squared from du. So let's simplify this. This becomes, the formula gives us 1/2 x squared minus 1 times inverse sine of x, and now the second integral, that is the integral on the right, is simplified to 1/2 times the integral of square root of 1 minus x squared. So this is what we have left to solve this problem. Let's go ahead and evaluate this integral without the 1/2. We'll come back and plug it in once we're done. So now we want to evaluate the integral of the square root of 1 minus x squared. That's where we use trigonometric substitution. Let x equal to sine of theta. Dx is equal to cosine of theta d theta. 1 minus x squared becomes 1 minus sine squared of theta, which is of course cosine squared of theta. So this integral now looks like this. It is the square root of cosine squared of theta times cosine of theta d theta. And this simplifies to the integral of cosine squared of theta. To evaluate this integral, we've done this many times before in earlier videos. We utilize the following trig identity. Cosine squared of theta is equal to 1/2 times 1 plus cosine of 2 theta. So the integral becomes 1/2 times the integral of 1 plus cosine of 2 theta d theta, and that of course is 1/2 times theta plus 1/2 times sine of 2 theta. Let's multiply everything by 1/2. We have 1/2 times theta plus 1/4 times the sine of 2 theta. But recall that sine of 2 theta is equal to 2 times sine of theta times cosine of theta. So this is 1/2 theta plus 1/4 times 2 sine of theta times cosine of theta. And finally we have 1/2 theta plus 1/2 sine of theta times cosine of theta. We need to go back to variable x. We recall our substitution was x equal to sine of theta, and that means theta is equal to inverse sine of x. We draw a right triangle like this and label this as angle theta. And sine is opposite divided by the hypotenuse, so opposite side will be x. And this is 1, and then the adjacent side is square root of 1 minus x squared. So all we need is cosine, and cosine of theta is square root of 1 minus x squared. So then rewriting this in variable x, we have 1/2 times inverse sine of x plus 1/2 x times the square root of 1 minus x squared. So let's return to the original problem. The original problem, recall, was the integral of x times inverse sine of x, and that was equal to 1/2 x squared minus 1 times inverse sine of x plus 1/2 times the integral of the square root of 1 minus x squared. We just evaluated this integral, and then we'll multiply everything by 1/2, and let's also go ahead and expand this part as well. So this is equal to 1/2 x squared inverse sine of x minus 1/2 times inverse sine of x plus 1/2 times 1/2 right here gives us 1/4 inverse sine of x, and then 1/2 again times 1/2 plus 1/4 times x times the square root of 1 minus x squared, and then we can add a c at the end. So let's simplify this. This is equal to 1/2 x squared times inverse sine of x. Here we have minus 1/2 plus 1/4. That's minus 1/4 inverse sine of x plus 1/4 times x times square root of 1 minus x squared plus c. And we can do one more thing. Since both of these terms have inverse sine, we can factor it and write the final answer in the following form: 1/2 x squared minus 1/4 times inverse sine of x plus 1/4 x times the square root of 1 minus x squared plus